All right. So while this part, if you just look at MnO4, it could be manganate or permanganate. Okay? But, what? No, this is manganate. Now I'm going to show you. The reason why is permanganate has a 1 negative charge. We have 2 sodiums. If we have 2 sodiums, they both have a positive charge, then this other particle, for which we only have 1, must have a 2 negative charge, and that's manganate. So this compound is sodium manganate. It's just a puzzle. Okay, you got to kind of figure it out as you go along. All right. So let's try this then. Okay, name this compound. Okay, so to name, when you have a compound that has more than 2 elements, and this one has 1, 2, 3, 4, then you're going to look on the list of common ions, see if you can't find some part of this that is a polyatomic ion. Okay, you want to have 2 names overall. So if this has 4 elements in it, you want your polyatomic ion to contain 3 of those elements. Or you want to have 2 polyatomic ions. We'll get to that later. Okay? Somehow you got to get it together so the name of your compound has only 2 parts. At this level in CP chemistry in high school, we're only going to be naming those compounds that have 2 names, a first name and a last name, not a middle name. Okay? So if you name something that has 3 names, you did something wrong. All right? All right, now, so let's look on this common ions list and see if we can find some part of this that'll take up a bunch of the naming of this compound. Well, that would be tartrate. Whoop, wrong one. Where's tartrate? Here's tartrate. C4H4O6. That's the right formula. C4H4O6. Okay? And that has a 2 negative charge. So magnesium on your periodic table has a 2 plus charge. And that would balance out that formula. Okay? 2 negative, 2 positive. 2 negative, 2 positive. That's a neutral compound. Okay? So then we're going to name this magnesium tartrate. Magnesium tartrate. See how we did it? Okay? Alright, so you've got to remember, we start getting into when you have more than 2 elements in a compound, try to find polyatomic ions to help you name it so you can come up with only 2 names. Got that? Alright, let's try another one. Okay, so name this compound. Okay. NH4 has a 1 plus charge. You look it up on that common ions list. It's right here. That takes care of 2 of our elements. Okay. Then we go to chlorine. That's going to be chloride, since it's on the end of the word. It's not a polyatomic ion. Polyatomic ions, you don't change the end of the word. You listening to me over there? When you have a polyatomic ion on the back of the formula, you don't change the end of the word. The only time you change the end of the word is when you have an element on the end of the formula. That makes sense? Chlorine has a 1 negative charge. That works out. So this must be ammonium chloride. Okay? Ammonium chloride is a fairly innocuous compound when you're using it in the lab, but it's a major component in an explosive so you don't want to play with this stuff. Alrighty, let's try something else here now. How about we do this? Put a 3 after this. Okay, there we go.
So we're multiplying aluminum.
Okay, so this is aluminum chloride. Where did the 3 come from? Well, what's the charge on the aluminum? Huh? Well, look it up on the periodic table with oxidation numbers. I gave you the reference. Look it up. And it's not just you. At least you're trying to answer it. But come on, people. I give you the tools. Just use them. What's the charge on the aluminum? 3. What's the charge on the chloride? What's the charge on the chloride? Where do you find chloride? Huh? No, chloride is 1 negative. Yeah, the number at the bottom here, this subscript, listen please, this is really important. The number at the bottom here is telling you how many oxygens there are in this polyatomic ion. The number and or charge at the top, or the number and charge at the top, number may not have a number which is 1, but at the top here, this is where we put the charges. So this is not 2 negative, this is 2 oxygens, and the whole thing has a negative charge. How many of these chlorides do I need to balance out the 3 plus charge on this aluminum? I need 3 of them, don't I? Okay. Well, what if I write this then? Balanced out there. Now, what if I write it like that? Does that make sense? Looks like I got 23 oxygens. The way that you show that I only have 3 chlorates is to put a parentheses around it the same way you would do it in algebra. And if you were multiplying 4 times 3x, you put a parentheses around it like that. Do the same thing here. Okay? This 3 means I have 3 of these things. In the overall compound, that means I have 3 chlorines and 6 oxygens. Does that make sense? Because we're multiplying everything inside like I multiplied over here, 4 times 3x. So this would be 12x. Right? Right? Isn't that 12x? Okay? So it works the same way. Only instead of the numbers being, here as coefficients, they're subscripts. We have a place for coefficients. We'll get to that in the next unit. But when it's just compounds, we use the subscripts like this. Yes?
What's the answer?
The name of the compound is aluminum chloride. Somebody asked, why is this ClO2 in a parentheses? This is why. That's how we show it. Does that make sense to you? This is why we have to put the chloride in a parentheses. Well, let me give you a name and let you work on one yourself, okay? Okay? Write a balanced formula for this named compound. Write a balanced formula for this named compound. What is the symbol for ammonium? That's aluminum. What's the symbol for ammonium? NH4. That's not the end of it. What else does ammonium have to have? A plus charge. Okay? What is the symbol for sulfite? SO3, 2 negative. Okay? In order to get a combination of ammonium and sulfite to balance out, to get the charges balanced out, how many ammoniums do I need? 2 of them. Have to have 2 plus charges and 2 negative charges. Okay? So now we're going to put it together. NH4 and SO3. And we're going to put it together in a way so that the overall compound has no charge. And we show this coefficient 2 as a subscript here. But to show that that's 2 ammoniums and not 42 hydrogens, we need a parentheses here. Okay? Write the correct formula for iron 3 thiocyanate. Iron 3 thiocyanate. Okay, so naming this compound then, iron 3 means we have an iron with a 3 plus charge.
So, but I thought iron was a 1 negative charge.
Iron doesn't have a 1 negative charge. Iron either has a 3 positive or a 2 positive charge. Now, thiocyanate has a 1 negative charge. sulfur, carbon, nitrogen is what thiocyanate is, and it has a 1 negative charge. Huh? That's what you do. You have to have 3 of these particles with a 1 negative charge to balance out the 3 positive charge on the iron 3. So when we put the formula together, we have FeSCN, and to show that I have 3 of them, I need a 3 there, but this is like I have only 3 nitrogens, and to show 3 thiocyanates, I need a parentheses. Okay. Capital M, little o, capital P, capital O. Okay, so you want to write the name for this formula. Y'all don't seem like the... Alright, so if phosphate has a 3 negative charge, and I've got 2 phosphates, 2 3 negative particles, gives me a total of 6 negative charges. What charge does the molybdenum have to have? 6. There's only one molybdenum, it's got to be a 6 plus. Okay? That's what gives us this formula right here, right? That'll work out, because if I got a 6 plus here, and this is added to a 2 times a 3 negative, I get a 0 charge. That's how I get that neutral charge. Alright, so now we got to name this. What is this called? No, you have to name this, because molybdenum has more than one oxidation number. This has to have a Roman numeral. Molybdenum has 3 different oxidation numbers here. Molybdenum 6. Okay? All right. Now some homework. All right.